Hai, Assalamualaikum. My name is Erni Suhaili binti Cik Muhammad Yusof with metric number 20211099157. So in this video, I am going to talk about symmetry element of the octahedral point group. This high symmetry point group have a lot of symmetry element. So this is the molybdenum carbonyl that I have constructed using skewers and also styrofoam balls. I will start with the center of symmetry. Here is the center of symmetry. Following with the C4 rotation, there are 3 C4 axes, but to bear in mind, there are 3 C4 axis and 3 C4 axis. C4 axis is one in which the molecule is rotated by 90 degrees. Let's see the C4 axis in this constructed molybdenum carbonyl molecule. So here the first C4 axis. Next, we see the second C4 axis, which is perpendicular to the first one. Alright, the third one, which is the last one, is here. So I think the C4 axis is the easiest axis to identify in an octahedral point group. I want to show the C3 axis. This one is much harder to find than C4, so let's give our full attention. There are 4 C3 axes. To take note, there is 4 C31 and also 4 C32. So I'm gonna put this molecule like this. This triangle indicate the tripod of the first C3 rotation. If we see the molecule at above, there are 3 atoms touching the surface and 3 atoms pointing up towards me. So we can see the C3 axis from here. Then what about the another 3 C3 axis? I'm gonna put the molecule like this again. Then the second one by this triangle that indicate the second C3 axis. So I'm gonna do the same action. Same goes to the third and fourth C3 axis. The next one is the C2 axis, which is the last set of C axis. There are 6 C2 axes in molybdenum carbonyl. The C2 axis is going to be difficult for me to explain if I just rotate here, so I choose to take the picture of the molecule and show it using this editing by me. Let's place one of the C2 axes. The first one is here. It appears to be 180 degree there. I have edited the molecule inside a cube to easily visualize it. The C2 runs through the center of the cube, bisecting the bottom left edge and the top right edge. There are a total of 6 C2 axes bisecting cube edge in this way. The next symmetry element to identify is sigma horizontal. There are 3 sigma h perpendicular to the 3 C4 axes. The other plane of symmetry is dihedral. There are 6 sigma d in this octahedral point of group's molecule. These sigma d extend along the principal axis. 2 atoms on one side of the molecule are related by reflection to 2 atoms on the other side of the molecule. There are 2 sigma d extending along of each the 3 axes for a total of 6. The last part is improper rotation. There are 3 S4 axes collinear with the 3 C4 axes. The first improper rotation, I'm gonna put the molecule like this, and this is the first C4 axis. Remember the S4 collinear with C4 axis. Look the molecule above. I will rotate it first to 90 degrees and reflect the molecule. The molecule shape remains unchanged. Second S4, we use the second C4 axis, which is here. Then let's see from above the molecule. I will rotate it to 90 degrees and reflect. The result is just the same as the first one just now. The action will be repeated to the third S4. The molecule's last improper rotation is 4s6, that is collinear with the 3 axis. I will use the first triangle as tripod as I indicate the C3. I put the molecule on the surface and look straight down at the molecule above. So I will rotate first for 90 degrees, then reflect the molecule like this. So this is the first one. The reflection leaves the molecule unchanged. The second part of S6 is that I will do the same action but with another side of triangle as tripod of the 3 axis, which is here. I will repeat the same action for the third with another side of triangle of the C3 axis. Here is the last triangle as tripod to indicate S6 from C3 axis.